Today we are going to talk about properties of logarithms, and the first thing that we're going to do on this sheet is exactly what you are doing on that worksheet. Okay, so we're going to solve logarithmic equations using properties of equality and properties of logs. So some of these are going to be no calculator, other ones you are going to use your calculator on. But the main thing we're going to do is we're going to tie this to exponential form. Okay, so we can use this definition of a log to solve equations containing logs. Okay, so when you're writing it in exponential form, that is when you are going to rewrite as the base, the answer, the exponent. So this would be 4 to the 5 over 2 power equals x. If you guys have finished that worksheet, then you know that you are going to be using these properties that we learned in chapter 6. So we can't forget that. Whenever you have a fraction, okay, what does each part of the fraction mean? Yes. Okay, so this is going to be the root. Whatever's on the bottom, whatever's on the top is the power. So if you are evaluating this, it is going to be the square root of 4 raised to the 5th power. What's the square root of 4? 2. 2 to the 5th is 32. So this is going to be your final answer. And I do want to see these steps. Okay, I want to see that you understand those. Alright, and then I want you to do B. So I want you to rewrite it here. Okay, so 27, and then what's the exponent? The x or the negative 2/3? Negative 2/3. So if it's negative, our first step is to do what? Put it over 1. So 27 is now to the 2/3. And then if third is the root, it would be the cube root of 27 to the power of 2. So can you simplify that step by step? Alright, so then the cube root of 27 was 3, and 3 squared is 9, so your value of x should be 1 over 9. Okay, so see how these are going to come back around? We have to make sure we know how to evaluate with your exponents, okay, rational exponents. The other thing we're going to use today, besides exponential form, is this property equality for logs. So this is really intuitive. Remember when we did exponential functions, we rewrote them with the same base? Because if the bases were the same, what else do we know was the same? The exponents were the same, okay? So with logs, if the logs have the same base, so if you have log base b of x equal to log base b of y, then whatever the logs are going to be equal. So then x is equal to y. So this is the property equality for logs. So if the log bases are the same, whatever the logs are of, you can set equal to each other. Now with logs, we do have to check for extraneous solutions. Okay? Why might there be extraneous solutions? When do extraneous solutions come up? When what? When what? When have we encountered extraneous solutions? Okay, when what is equal to less than 0? What does that mean? Let's expand on that. Yesterday we learned something special about logs, right? Yeah, we did talk about the inverse. It's the what? Okay, so you have restrictions on your x values. The x values are part of the what? The domain. Okay, so if there's restrictions on the domain, then you have to check for extraneous solutions. If it's all real numbers, you don't have to check. That's why we never had to check with exponential equations, because you didn't have to worry about that. What can't you take the log of? 4. Yeah. Okay, so you can't take the log of 0 or negatives. Okay, which is why yesterday we wrote out a bunch of times x had to be greater than 0, right? That was your domain. That's what it means. You can't take the log of 0 or negatives. And then again, the reason why we have to check certain equations is not others is based on the domain. Okay, so since the domain is not all real numbers, we need to check for extraneous solutions. So when the domain is not all real numbers, that is when we have to check. Do you guys remember other types of things we had to look out for? Other domains that were not all real numbers? So a lot of work with that in chapter, I think it was beginning of chapter 6. Yeah, what other functions didn't have a domain of all real numbers? We had to check these when what? We had to do a lot of checking in chapter 6. Nope, you can plug anything into that. Yes, square root or any even root. And also with fractions, what can't you have in a fraction? No, you can't have a negative. You had even roots, you can't take the even root of a negative, but with fractions, what's the problem? When do you get an error? Yeah, when do you get an error in your calculator with a fraction? With what? When you get an error with a fraction. Thank you. When the denominator is 0, you can't divide by 0, right? Okay, so when you're solving the equation without a calculator, okay, then this property of equality is likely going to be applied. Okay, so we're going to use equality prop of logs. That says if these two are the same, I can take whatever the logs are of, which is the x squared minus 8, and I can just set it equal to 2x. This is very similar to what we did with the exponents. Okay, now I have to solve this for x. What am I going to do? Yep, move everything to one side so you can factor. When you move, don't forget to do the opposite. So I'm looking for two values that multiply to negative 8 but add to negative 2. Yep, negative 4 and 2, good. So then when I set them equal to 0, remember that you do the opposite. So x is negative 2 or x is 4. Now we are going to check. When you check, you can only work with one side of the equation. And you need to make sure that you do your plug-in step. So you have log base 3, and then this is negative 2 squared minus 8. If you plug this in and you have an exponent, you should put that in parentheses, because without it, it means something different. And this would be 2 times negative 2. Okay, so then when you are simplifying, we have log base 3 of negative 2 squared, which is 4. 4 minus 8 is negative 4. On this side, you also have negative 4. So be careful. This is the same on both sides. That is true. But can I take a log of a negative? Nope. So one thing you're going to have to be able to do on your test, so I want you to practice it, is make sure you can explain why the answer doesn't check. Okay, so you can't take log of a negative, and that's why this solution is extraneous. Okay, we also have to check x equals 4. So we have log base 3. So again, do your plug-in step. That's your first step. And the reason why you can't go across the line is because if you do any operations on either side of the line, okay, then that means you're assuming this is equal. We don't know if they're equal, so we can't use those properties. Okay, so 4 squared is 16. 16 minus 8 is 8. 2 times 4 is 8. Both of those are equal and it's positive, so that checks, which means your only solution is x equals 4. Okay, so I want you to start B. So when you're using your property of equality, I'm going to write mine over here just to give myself more room. And you're moving everything over to one side so that you can factor. When you're factoring and you have a number that's not prime, you have options. So it can either be 6 and 1 or 3 and 2. A lot of times, I know you guys start with the smaller ones, but then if you're multiplying to a positive and you're adding to a negative, both signs should be what? Negative. What's the only thing that multiplies to 1? 1. So you have to do 1 times 1. So this would be negative 2 and negative 3. That does add to negative 5. A negative times a negative is a positive. And then when you're setting each one equal to 0, okay, I'm fine if you're doing this in one step. Add 1, divide by 3. Add 1, divide by 2. And then we have to do the checks. Okay? So the first thing we're going to check is x is 1/3. We're going to do this step by step. So when you have log base 2 of 6 times 1/3 square plus 1, anytime you have an exponent, you should be plugging this in a parenthesis. And then this is 5 times 1/3. Okay, so if you're doing 1/3 squared, what is it? 1/9. 1 squared, 3 squared. Okay? When you're multiplying a fraction by a whole number, you multiply it by the top. So if you have 6/9, what goes into both numbers? 3. So if you divide by 3, it would be 2/3 plus 1. When you're adding 1, and you have a fraction, you need a common denominator. What is the fraction equivalent to 1 that has a denominator of 3? 3 over 3. So if you have 3 over 3 and you add that to 2 over 3, what is it? Yeah? Okay, and then look, 5 times 1/3 is what? 5 over 3. No negative, so that's going to check. Okay, so this is what you should have. This is your step-by-step way to check. Okay, and then let's check with the 1/2. So you have log base 2, 1/2 squared plus 1, log base 2, 5 times 1/2. Okay, so I want you to see if you can use this as your model. And if you look at this side, you really know what it should be. You're just verifying that that's what happens, right? What's 1/2 squared? 1/4. So if you do 6 times 1/4, what goes into both of those? 6 and 4. 2. And then if you want to write this so that this has the denominator of 2, what's the numerator going to be? What's the numerator going to be? The bottom is 2. What does the top have to be 1? Well, where were you guys? Okay, so once you see that those are the same, yay, both of these are solutions. Okay, so x is 1/3 or x is 1/2. That is your final solution. They both work. What happens if you check and neither of them work? If both of them have negatives in there? No solution. Okay, what if you plug it back in and it's not extraneous, but they don't match? Do you know what that would tell you? Yeah, you made some kind of calculation error. Okay, if you plug them in and there is not an issue that arises because of negative logs, okay, then it's most likely that you made some type of calculation error. Okay? Alright, any questions for me on the front side? Alright, the back side is going to feel very new because you're going to be learning some new properties. The good news is that these are derived from properties we already know. So remember that logarithms have a relationship with exponents. So you can derive these properties of logs from the properties of exponents. Remember that when you're multiplying variables with the same base, what do you do with the exponents? You add them together, okay? So we're going to see that we have a similar property here, okay? And then when you divide, what do you do to the exponents? Subtract. There is going to be one more. That's when we have the power to a power. When we have a power to a power, that is when we multiply them. And we'll talk about that as well. Okay, so when you're multiplying, okay, that is going to be addition. When you divide, you're going to have subtraction, and that's what we're going to use for our properties. So the first one is the product property. And when you have the log of a product, it's equal to the sum of the logs of its factors. Okay, so we're going to write out our property. It is log base B of m times n. And we're going to be able to use this property in both ways. Okay, in two different ways here. Okay, so this is going to be the log base b of m plus the log base b of n. The quotient property, we know that quotient means it's the result of division. So when you divide them, okay, we are going to use subtraction. So this is log base b of m minus log base b of n. The m and n are just placeholders for values, so those can be numbers, those can be variables. So log base b of m minus log base b of n. Okay? So we're going to look at a couple of different examples here. So for this one, if you are given log base 6 of 4 plus log base 6 of 9, we're going to be able to rewrite that. Okay, and then, so when you have the log base b of m plus the log base b of n,
Okay, so when is this done?
52. So when you have this, you can go in either direction. So the m and the n can be multiplied together. So this would be the log base 6 of 4 times 9. And this is a situation where it would be helpful because what's 4 times 9? 36. Now, doesn't this look like a problem that you guys did yesterday? Okay, so do you know what the answer is, or should we write it out as an exponent? Yeah, it's 2. Okay? Because 6 to what power is 36? 2. Thought somebody was raising their hand for a second. All right, let's try this division one. All right, so let's do log base 5 of 16 minus log base 5 of 2. Do you guys think you could write that as the next step? Okay, and then, so this would be log base 5 of 16 divided by 2, which is log base 5 of 8. Now this you can't rewrite. This you can't solve yet, okay? You won't be able to do it without a calculator yet. But don't worry, we're going to learn how to do things like that this week. So then this would be your final answer, okay? I know you were worried, but you didn't know how to solve it. So don't worry. I'll show you. And then your power property is log base b, okay? And then this is going to be something with an exponent. So it's going to be a to the power of p. So log base b of a to the power of p. So when you have the power property, you are going to multiply, just like if you had getting a workout today. Okay, so when you rewrite it, it's going to be p times log base b of a. Okay, so the logarithm of a power is the product of the exponent and the log of the base. So this power comes down in front, and then you're going to multiply. Okay, so this is going to be useful in a situation like this, where you have the log of 1,000. Okay, if you can't see the base, what is the base of the log? Yep, it's 10. So let's rewrite it as a power. So this would be log of 10. Do you guys know 10 to what power is 1,000? 3, because there's 3 zeros. Okay? So now what we can do is bring that 3 in front. 3 times the log of 10. So remember, what's the base of the log, this log? 10. If the base is the same as this, what does that equal?
Wait, are you saying 10 is the base of the log, or is it like...
Yeah, it is. I'm saying 10 is the base of the log because you can't see it, because it's the common log.
Oh, that 10 isn't supposed to be like...
The second step is
Yeah, so this one, you don't see the base because it's the common log. And if you have the same base as what this is of, which the common log is 10, then what is the solution for log of 10? And if you aren't sure, just remember, the log of 10, if it was the log of 10 equals x, okay, remember you can't see the little 10 here? 10 to what power is 10? 1. So this is going to be 1. So 3 times 1 is 3. Okay, so you won't have to do ones like this part yet, but that's where we're headed, okay, with the properties. Okay, what we're going to do is we are going to rewrite logs using given values. So for example 3, okay, you're going to use the following values. And I don't think I made this line long enough, so just bear with me. So you're going to use log base 4 of 2 equals 0.5. You're going to use log base 4 of 3 is approximately 0.7925. And log base 4 of 5 is approximately 1.1610. And we're going to use those to approximate the value for given expressions. Alright, so this is going to be the strategy with these. When you're using these logs to approximate the values, you are going to try to rewrite each as either a product, a quotient, a power, or a combination. So, or a combination of product and quotient, or quotient and power. Okay, so when you are doing that, it's important to focus on what the logs are of. Notice that it's log base 4, log base 4, log base 4. The numbers that we're going to focus on are what the logs are of. So 2, what else? 3, and 2, 3, and... Okay, so we're going to try to use 2, 3, and 5 to make 30. Okay, so what's a way I can make 30? Okay, so that one you can multiply 2 times 3 times 5. 2 times 3 is 6, 6 times 5 is 30. Okay, so you're going to rewrite it as 2 times 3 times 5. Really, you can rewrite it in any order, right? You could write it as 5 times 3 times 2, that's fine. Focus up here. And then what you're going to use is your property of the product. Okay, so if you can rewrite this with the product property, then you can substitute the values that are given. Okay, so when you multiply, you can split them up with addition, and then they told you that this was 0.5, this was 0.7925, and this was 1.1610. Okay, you can use your calculator for that. So I want you to find the sum and write it in the box. And then I want you to start thinking about B. And how can I rewrite 64 as a product, a quotient, a power, or a combination of those things with 2, 3, and 5? Nope, that's a good question. If you use it more than once, that's actually going to be a power. So like if it was 3 times 3, you'd write it as 3 squared. You could do that. Which one are we probably not going to use for this one? Yeah, why 5? If you're multiplying something by 5, then it should end in a 5 or a 0, right? Okay, is there a way that we can rewrite with 3 or 2? Okay, and if you're not sure, what's a strategy that we've been using to break down numbers? Yeah, the factor tree, right? So we know 64 is 8 times 8, and 8 is 2 to the third. 2 to the third. What's 2 to the third times 2 to the third? 2 to the 6. So if I can rewrite it as a power, okay, then I can use my power property. That's exactly what I'm going to do. So this would be log base 4 of 2 to the 6. 2 to the 6 is 64. You can always rewrite it as long as it's the same value. 2 times 3 times 5 was 30. 2 to the 6 is 64. Now I can use my power rule, which is where the exponent is multiplied by the log base 4 of 2. Okay, so now I know what log base 4 of 2 is. I'm just going to plug it in, and this you can do without your calculator. What's 6 times a half? Yep. Okay, so now I want you to start thinking about this one. They already have the division in there for you, so right away you should start thinking about what property. Yep, the quotient. This was the power property. So right away, yeah, let's use the quotient. Now, when you use the quotient property to rewrite this, you have log base 4 of 6 minus log base 4 of 5. One of those we know. We know log base 4 of 5. Do we know log base 4 of 6? Do we know just that one? No, but do we have something we can do to make 6? Yes, we can rewrite it as what? Yep, 3 times 2. Okay, so we use the quotient property and we use the product. So with the product property, that means I can split this up into the log base 4 of 3 plus the log base 4 of 2 minus the log base 4 of 5. Okay, so go ahead and plug in your values and then do your calculation. Okay, so plug them in, write them down in this step. Okay, and then I want you to start thinking about example 4. And go ahead and check your answers for A and C, make sure they're the same. Okay, and then what questions do you guys have on example 3? Wait, this?
No, no, never mind. The other thing, so that,
You don't, you're just plugging in this. You're just doing 0.5 plus 0.7925 plus 1.1610. Yeah, you're just doing 6 times a half. This plus 0.5 minus 1.16. You shouldn't be plugging any logs into your calculator. So they're going to give you what the decimals are, and then that's why you're rewriting them using only these numbers. You can't use whatever you want. You have to manipulate it with what they've given you. Eventually we will do the logs in the calculator, just not in this section. Okay, so based on what we did above, where we had to rewrite these using the properties, we should notice here that you have a property that you can rewrite. If you have subtraction, what property is that? Subtraction goes with the quotient. Okay, so let's rewrite with the quotient property. So we'd have log base 3 of 56 divided by n equals log base 3 of 7. Okay, so because you have that minus sign, we know that we can rewrite this as a quotient, and then we're going to combine it with what we did on the front. If the logs are the same, okay, you set them equal. You do not divide them. Why would dividing the logs not work to get rid of them? No. Whenever you're solving an equation, you use inverses, right? So division only undoes what? Multiplication. This is not multiplied together. This is the log of 7. Okay? Do you guys remember geometry, like you'd find the tangent or sine of something? And I always have people that try to divide the sine from whatever it's of, but that's not allowed. You can't do that. They're stuck together. Okay? You can only undo this with the inverse, which is an exponential function. All right, now once you use that property of equality, okay, then you have to solve this for the variable. For some reason, this is something people forget how to do. How do you solve that for a variable? Yeah, you always multiply by the denominator. If you have something in the denominator that you need to find, multiply by it. Okay, now obviously this is something that you would look at and see, right? It's a simple example of one of your multiplication facts. Okay, and then it says to check your solution, and again, that's because you could have an extraneous solution. Okay, so we're going to check x equals 8, so this would be log base 3 of 56 minus log base 3 of 8 equal to log base 3 of 7. So the only side we have to work with is this side. So we can use our log properties to simplify, and then we just make sure on both sides you have the positive values and those are the same, so that is going to be your solution. Alright, and then for this one, for B, I want you guys to decide which one of these rules up top are you going to use to rewrite this. Yep, how do we know it's the product? What's the giveaway? Yep. So when you're doing the product, you are multiplying x by x plus 2. When you're multiplying those together, what are we going to have to do to simplify? Distribute. So you have to multiply and then I'm going to just turn this back into parentheses. If you have parentheses, you can use double parentheses or brackets. X times x is x squared, x times 2 is 2x. And now we can use the property of equality for logs, which is if you have log 2 and log 2, you can just set whatever the logs are of equal to each other. Okay, and then I want you to find your two solutions. And we are going to check them. Yeah, just make sure you show your steps. Alright, what multiplies to negative 8 but adds to 2? Plus 4 minus 2. Okay, so then your x is negative 4 or your x is 2. Okay, and make sure when you are checking that you're doing the plug-in here. There are some cases where even if your answer is negative, if you plug it in, depending on what it is, it could be squared, you could have a minus a negative in there that would change to a positive. You have to plug it in and show where the problem is. Okay, because right away we have a problem, right? Negative 4 plus 2 is going to be negative 2. Be careful. You can't multiply a negative by a negative with your logs and say it's a positive. This is just like the square roots. When we were checking the square roots, right? You can't multiply a negative square root by a negative square root. This only works if these are positive. So you can't take log of a negative. So that is extraneous. I'm going to sneak my other check in here. Sorry, I used too much room over there. Bless you. So we're going to check x equals 2. So this is log base 2 of 2 plus log base 2 of 4 plus 2 for 2 plus 2. Okay, and so this would be log base 2 of 2 times 4. Log base 2 of 8 equals log base 2 of 8. Yay! Okay, so then this is going to be your only solution. Okay? So there's two things that you're gonna do tonight. Well, some of you. You're gonna finish your log worksheet, and then you're gonna do your textbook homework, and there are two different places to turn them in on Google Classroom.